Alright, so far we've learned how to solve equations systems of equations first by graphing, and then we've worked on solving using substitution. So this is a third method that we can use for solving by a method called elimination. Now, you may ask, why do we need three different ways to solve? Well, each one has its advantages. If you're solving by graphing, well, that's great, except that it's really tedious if you don't have a graph paper handy. If it doesn't have whole number answers, it's going to be virtually impossible to solve using graphing. So then you'd have to move to substitution or elimination. Each of those has its advantages. Substitution's really nice if you already have like one equation that's like y equals 3 or x equals 2, then that makes that really easy. So there's a definite advantage if you have that. Also, if one of the equations is already in y equals something form or x equals something, even if it's not a number on the other side, even if it's an expression. But if it's in what we call standard form, where it's something times x plus or minus something times y equals some number, then elimination is really probably the most convenient method to use. Now, as we're looking at this, elimination we're going to do by adding or subtracting the two equations with each other. If you look at these two equations, one thing you'll notice is that both of them include negative 1y, which means since they have the exact same number in each of y, this is a good one to solve by subtracting. Now let me show you how this is done. So I'm going to rewrite the equations over here. Negative 1x minus 1y equals 5. And negative 2x minus 1y equals 15. And I'm going to subtract. And all I'm going to do is I'm going to subtract like terms from like terms. Now, I can do this because if the two sides are equal, if I subtract one side from, if this does in fact equal 15, then I'm essentially subtracting 15 from each side, which means they should still come out equal. So that's how we can justify doing this. I'm still subtracting the same thing from both sides of the equation. It just so happens that the two things look a little different. Now, I can do like terms, so negative 1x minus negative 2x. Now be careful, minus a negative really means plus positive 2x. So again, use your calculators if you need to with it. So negative 1 minus negative 2 is negative 1 plus 2, which gives me 1x. Negative 1y minus negative 1y are eliminated, thus the elimination method. Because they're the same thing, you subtract them out and they go away. And then 5 minus 15 gives us negative 10. So I end up with 1x, which of course is the same thing as x, equals negative 10. Now I have my solution for x, and now I can plug it into either one of the equations to find y. So if I plug it into the first equation, negative x minus y equals 5. Now do be careful, remember negative x is not negative 10, it's negative 10, which really makes it positive 10. Okay, did I just lose you there? Remember, this is negative x. If x itself is negative, that means negative x is positive, because negative is the opposite of whatever x is. So if x is negative, negative x is positive. So 10 minus y equals 5. If I subtract 10 from both sides, don't forget this is not y left, it's negative y. And 5 minus 10 is negative 5. And then I need to divide through by the negative 1, which gives me y equals positive 5. So my solution here is negative 10, 5. Alright, so there's one good example of solving by using elimination. So let's look at another one. Alright, this one here, again, I have two numbers that are exactly the same, 8x and 8x. So again, a good choice here would be to do subtraction. So I'm just going to rewrite both of them over here so I have some room. Oops. 8x plus 7y equals 11. Now this one fortunately doesn't have those negatives, so less likely to make the careless mistakes. So 8x minus 8x, of course, there's our elimination. My x terms are eliminated, leaving me with just y. 5 minus 7 gives me negative 2y, and 1 minus 11 gives me, or 1 minus 11 gives me negative 10. Now I have one more step here to get y. I need to divide through by negative 2, so I get y equals positive 5. And now I can plug that back into either equation. So let's say I use the first one, 8x plus 5 times y, which is 5, should equal 1. So I get 8x plus 25 equals 1. I'm going to subtract 25 from either side. 8x equals negative 24. Going to divide through by 8, and that gives me x equals negative 3. So my solution for the equation is negative 3, or system is negative 3, 5. Alright, so both of those were examples where we could subtract because I had the exact same y value in the first case, and in the second case I had the exact same x value. So let's look at one more example. Now in this case, we don't have the exact same value. In fact, we have opposite values, 9x and negative 9x. Well, since here I have a positive 9x and a negative 9x, instead of subtracting, all I'm going to do this time is I'm going to add the two equations. So now the one thing is make sure you don't forget halfway through and add some things and subtract others. So everything's being added here. So 9x minus negative 9x is 0, so that goes away. 7 plus negative 10 is negative 3y. And negative 15 plus 6 is negative 9. Now I need to divide through by negative 3. Now I'll get y equals positive 3. And then I can plug that back into either equation. So let's do the first one. 9x plus 7 times y, which is 3, should equal negative 15. So I get 9x plus 21. I'm going to subtract 21 on both sides. So I get 9x equals negative 36. Divide by 9. And I get x equals negative 4. So my solution is negative 4, 3. Alright, so those are some good examples. Now there is one other thing that might happen, so let's look at an example like that. Alright, so this last example is just a little bit different because we don't have the exact same things. So the first thing we're going to have to do is we're going to have to change one of the equations so that you have the same coefficient to your x or to your y. The easiest one is, since we have negative 1x, if I just multiply that by 6, that'll give me negative 6x. But I can't multiply just the one number. I've got to multiply the whole thing. So I'm going to do is I'm going to multiply this entire equation by 6, which means this equation is now going to be negative 6x minus 18y equals 120. So remember, it's distributive property through, so you've got to multiply it times every individual term. And then our other equation is 6x plus 8y equals negative 20. And now, since I have 6x and negative 6x, I can just add them. 6x and negative 6x will eliminate. So I have negative 18 plus 8, which is negative 10y. And 120 plus negative 20 is 100. And then I can divide through by negative 10 on both sides. So my y value will equal negative 10. And then I can pick either equation to plug in to solve for x. So if I take 6x plus 8y equals negative 20, and I simply replace y with negative 10, then I end up with 6x minus 80 equals negative 20. I can add 80 on each side. So I get 6x equals 60. And then if I divide through by 6 on each side, I get x equals 10. So my solution for this one is 10, negative 10.